Okay, are we ready to make AM with the FT101? Remember, we found that really cool filter in the last video. We figured out it was an AM filter. And we want to install it in this board and then rewire the mode switch over here, rewire the mode switch so that we have AM capability. So if you'd like to put AM into your FT101, and I'm just going to do the basic AM conversion on the transceiver, not the hi-fi conversion that WA1HLR has done, but just the basic AM conversion. This is the video for you.
Seemed like every class was AK something. I knew the name before I knew what it was.
Anyway, good to hear you. Thanks for being part of the net, and we'll look for you next week. Let's see, I got Dave checked in. Let's see if we have other check-ins for the lonely guys before we proceed. Go ahead.
WA1QIX and the lonely guys, N2YKX.
So tuning up in AM is not difficult. Just do a normal tune, either in the MOX position or using the PTT in the handset, in the tune position. Dip the plate. Okay, we're over 100 watts. Now all you really need to do is bring the RF drive down until we're at the 150 milliamp point, or lower. Right about there. As you can see on the output meter, we're doing about 30 watts out. Let's bring it down even a little more. Okay. That's a little over 20 watts out, 23 or 24 watts out. That's probably a good place to run this thing in the AM mode. Let's go to AM. Let me get my monitor receiver set up so we can hear something. Now remember, we're using this horrible microphone, and there are no mods at all to the transceiver in regard to the audio input. We know that we're very light on the mic input because I have it absolutely at maximum, so we know we have a mismatch. 1, 2, 3, 4. 1, 2, 3, 4. This is AM. As you can see, the meter is just moving as I talk. 1, 2, 3, 4, 5. 1, 2, 1, 2. Now let's look on the scope. This is an AM transmission. Hello, 1, 2. Testing 1, 2, 3. Hello, test 1, 2. We also hear a little bit of hum in the background. This is where you see if your filter capacitors in your transceiver are actually in need of replacement. And I can tell with that modulation and with the hum I'm hearing that we probably could use new caps in the transceiver. Here we are looking at the filter board, and we're going to be installing the crystal filter in this slot right here, taking the place where the CW filter would normally live. Remember, when you remove that board from the radio, to use your wrist strap and to be very careful soldering. So that's the next step. We're going to be removing that board and installing the new AM filter. I'd like to go through the circuit on that board and show you how the crystal filters are selected. The Japanese engineers who designed the Yaesu hybrid radios in the 60s and 70s were very much aided by a mature domestic semiconductor and radio industry that could produce good quality, low-cost, commercial-grade parts in tremendous quantities. Aided by 1950s tube transceiver designs and later by solid-state designs, you will recognize their many circuits as being familiar and closely resembling those you would see in the radio handbook type circuits. It's all very standard, discrete design. Very few avant-garde techniques were used in Japanese design. All of the stages are fed power in a parallel fashion that we're used to, usually from a single supply or set of supplies. If you're familiar with the original 1970s solid-state circuit design books by Doug DeMaw and Wes Hayward, you're going to find examples of almost every circuit used in these radios described very clearly in these books. And like the tube techs of old, this new breed of solid-state radio techs were brought up on this type of discrete design circuitry. The FT101 utilizes late 60s design technology along with the new silicon-based bipolar transistors, JFETs, and MOSFETs in discrete stages. Some feel that this early 70s era with circuit boards and cordwood construction represented the pinnacle of discrete solid-state radio design. The crystal filter selector circuit on PB1080 is a great example. We could probably estimate the filter termination impedances just by looking at this schematic. The crystal filter is fed by a FET source follower. On the input side, the impedance is defined by a combination of two 5.6K resistors in parallel. This is your bias feed, and the output impedance of the FET source follower. Plus, it looks like they put a 330 ohm series resistor in there to raise the impedance. The JFET source follower has an output impedance that's based solely on the resistor values and the transconductance, or GM. Transconductance relates to the current through the output of a device against the voltage across its input, and it's described in milliamps per volt, or the more modern term, millisiemens. The GM that the device exhibits at its bias point is a key characteristic to determine the output impedance of the source follower. We can estimate the source current in milliamps based on the 2 volts they show on the diagram and the 2.2K resistor. That's going to give us about 1 milliamp through the drain. Looking at a typical data sheet, I would expect that the transconductance, or the GM, would probably be around 5 milliamps per volt. So the R out of the FET, and let's look at all these numbers, would be 2.2K divided by 0.005 times 2.2K plus 1. So if you do the math, that's 183 ohms. By adding the 330 ohm series resistor, we get up to 513 ohms. Then we parallel that number with the two 5.6K resistors. That's 2800 ohms, and you get to the 433 ohm number. You might remember that we used a 200 ohm termination in my experiment in the last video to evaluate the filters. One viewer suggested that I should have used a 1:9 trifilar wind on the toroid, and unlike that would give 450 ohms. Good on you, mate! That's what we'd say in Australia anyway. It turns out that that was likely a closer match to a correct value. Next, let's look at how they did the switching. They actually used switching diodes the way that they were designed to be used, to switch something. Forward-based diodes can be used as switches to conduct or block DC, audio, and in this case, RF. Reverse bias diodes block RF, in this case the RF in and out of the filters. Here is a positive switching example. You can clearly see that this clever setup allows one filter at a time to be selected by putting positive on either of the control lines. The FT101 circuit switches by turning on the diodes by pulling them to ground through the mode switch, opposite. With the use of bypass caps and chokes, they cleverly turn on one set of diodes while the other set remain off, thus selecting individual filters from the mode switch. First thing we have to do is remove these two 0.01 microfarad capacitors from the back. Got some fuzz from Q-tip. Okay, let's remove these two capacitors. This shouldn't be hard. They're just going to pop off. Okay, that was easy enough. Now we're going to install the filter. It looks like we need to kind of shove some components over a little bit. Let's see if this is going to go in. Would be nice if it fit, right? It's always easy to actually try to do something, you know. Be a lot easier if we cleaned out the holes for the filter. Looks pretty good. Yeah, I don't have a problem with that. And over here we should have our nuts and lock washers. Okay. Okay, let's get this baby tightened down. Just a little bit of solder on the pins. Okay, good enough. Okay. Okay, that's going to be it for the board. Just make sure everything looks okay. Yeah, it looks okay on top. Can somebody tell me why they labeled it upside down? That doesn't make any sense. But that was done a long time ago. Next, this is going to get reinstalled into the radio, but we have the switch modifications next. Oh boy. This is where we got to get on the mode switch on the front of the radio. This should be interesting. Okay, time to put PB1080A back in. It now has both the XF32A narrow single sideband filter. That will be working in the CW and single sideband modes. And we now have the YTK AM crystal filter installed in the CW filter slot. So let's get this board back in. And the screws should be here. Yeah, here they are. Always tricky to get these back in lined up just right because there is some play in the slot, of course. Oh, there it goes. Let's get the other one in. So here's a trivia question. This is the original FT101 design. Now, as the radio evolved through the years, and really these were long years, not like today where years go by, lickety-split. But back then, years took a long time, and you could develop a whole new radio. And what do you think happened to the quality of the radio as years went on? Now, when you're in production with a radio and you're trying to cut costs, you're always looking to, use components that are less expensive. And, of course, you're trying to add features at the same time. So that's two competing things, add value, and at the same time lower cost. By the time that Kenwood got involved in making a very similar radio, like the TS520, for instance, they decided that Yaesu had gone a little too far here, and they were going to go with very simple boards and point-to-point wiring between the boards and reducing a lot of these connectors. And the board slots were a great idea, very high quality, but these are expensive parts. So as the radios evolved, you got more features and you got less cost of manufacture at the same time. So that was how this evolved. So you're never going to get the same quality that they had in these original radios where they were just trying to get in the market with something that worked. And of course the engineers had full command, and it wasn't a matter of cost cutting as much as it was getting a quality product out. So these things are built like a battleship compared to modern radios. So early radio or late radio, all of the action for the conversion to AM is going to be over in this area around the mode switch. Now these look different model to model, but you will need access. So I am going to remove this plate here and move it out of the way. We're going to be removing the knob, loosening up the hardware so that we can move the switch back a little bit and get at things. So that's the first step. Before we even get anywhere close to the switch, we need to move some things out of the way, get that switch freed up a little bit so we got access to the terminals that we're going to need to work with. So I'm going to loosen up this knob here. Let's get this guy out of there. Okay, that guy didn't want to come off. This is just going to make that mode switch easier to deal with. Just going to take that hardware off. Okay, so now the mode switch is loose. Let's get that top plate off. Okay. So this little tie right here is going to have to be snipped off so we can separate the wires easily. I also want to point out this point right here where there are two yellow wires coming into the card. One of those wires goes up to the heater switch. We're going to be removing one of those. But let's get things loose in here. We also are going to be using the ground on the microphone. So that's a little bit hard to see even. I guess you can see it here. This bundle here is the ground. Anyway, that's what you're going to be working with. It's not great, guys, but let's get wires loosened up a little more so I can identify them for you. So the first thing I'm going to do is I'm going to move that wire bundle back a little bit by using the little Princess heat gun. Let's just get that softened up a little bit so I can move that bundle back and give us a little bit more room around the switch. We're just trying to get a little more room around the switch. Okay, that's better. Just making a little more room around the switch so I can get at it easier. It's difficult to see what's going on here, but I'm going to attempt to show you some of the various features. First of all, this black thing right here, you see this black thing? That is the diode. Now in a modern radio, that's going to be a 1N914 or 4148 style, but in these old radios, they use these silicon rectifiers, kind of equivalent to a 1N4001. That's the diode, okay? So we're seeing a red wire, and we're seeing a blue wire, and then we're seeing a connection that has some yellow tubing on it. Okay, 1, 2, 3, 4. It's those wires we're going to be fooling with along here. So let's go through them one at a time. Okay, some of you want to do it right by the book. So here's the basic maintenance manual instructions on how to do the AM conversion on the FT101. Read through this carefully, and I will put a link to the maintenance manual in the description. Others are, want to do it step by step, and step by step we can read through these various instructions, and this will help you to go one wire at a time and do the conversion. And then some of you are visual and you want to see something. So here's the before and here's the after, and this should be something that you can follow very closely, and you'll very quickly be able to orient yourself around the switch. Pin 1 and 2 are shorted together with a jumper. Pin 3 is the blue wire, and that's also where the diode comes off. So blue is pin 3. Pin 4 is the yellow wire right here. Okay, that's going to be an important wire for us. So we're going to be messing around with those wires. We're also going to be fooling around up here with one of these yellow wires and reassigning it. So I've done some prep work, and I've got the switch moved out of the way, and I just noticed there's some electrolytic capacitors that I haven't changed yet. Remember, I still have the kit, and the kit has caps available to change out the 2.2 mic 160. I believe this is a 470, and this is 100. Those can be changed out in due course. I'll probably get in there and change those out behind the scenes. I'm just changing them out as I see them as I go. So we'll get the rest of them in there eventually. There's different colored wires that are going to help us with the switch, but we're going to go all the way around the switch in this section. The first thing we're going to be doing is we're going to remove the red wire on the switch terminal 1 and 2. That's this red wire right here. We're going to remove it from 1 and 2, and we're going to ground it onto the microphone's ground. There's a ground wire right here. That's where we're going to put that red wire, from there over to here. Next, we're going to leave the jumper in between 1 and 2. There is a jumper there already. We're, however, going to cut the jumper that comes off pin 2 and goes all the way around to terminal 5, which is down here. That's also the place where the diode goes. We're going to cut both the diode and that jumper on the terminal 5 side down here. There's now no connection at all to terminal 5. Okay, it's going to be open down here where the diode and the wire went and the jumper went. We're going to leave the blue wire on pin 3, and we're going to use that loose jumper with the tubing, and we're going to short that over to terminal 3. Now you will see that 1, 2, and 3 should be jumpered together on the switch section. Next, we're going to remove the yellow wire from terminal 4. That's this one right here. And we're going to take that yellow wire and we're going to attach that to the now open terminal 5 down at the bottom of the switch around there where the diode used to go. And we're going to take the end of the diode that we cut off, its cathode, and we're going to bring that to terminal 4. Now, that wire that we attached to pin 5 came off that terminal. So now we're going to be bringing the diode that we cut off, the cathode of that diode, back to terminal 4. So now the diode is basically between terminals 3 and 4. 3 is the anode and 4 is the cathode. Next thing we're going to do, and we're almost done, we're going up here and we're going to identify these 2 yellow wires that are on the plug-in card socket. Once we have that wire that goes to the heater switch, not the front mode switch, we're going to attach that to terminal 4. And you might remember there was another yellow wire there originally. We moved that wire to pin 5, right? So now there will be a diode cathode on terminal 4 and the new yellow wire which goes to the heater switch. So that completes the modification of the switch. A little hard to follow. What was the hardest part? I think the hardest part was getting down to terminal 5, clipping the diode and the jumper. Even though it's easy to clip something, you have to have some pretty sharp, narrow clippers to get down in there. The other 4 connections on top are not difficult. So again, the blue wire stays where it is on pin 3. Moving that yellow wire from terminal 4 that was originally on terminal 4 and attaching it down to the new open terminal 5 was probably the second hardest thing. But that's a quick solder connection. Really, the yellow wires are the difficult ones to keep straight, but it wasn't too bad. Now I'm going to tighten up the control to the front, give it a good inspection, make sure to buzz things out, and then we'll see what we've accomplished. Okay, so these are AM signals. This is what it sounds like to pick up an AM signal when you're in the lower sideband. So let's try our new AM mode, at least on receive.
All the parts I had on hand, except the driver transformer, because I gave the Viking 2 driver transformer away.
Very happy with that.
I have a G76. I really like that ring. It does direct. The one I have somewhat.
Wow, I have to declare victory here. Now, I haven't tried this on transmit yet, but I'm going to declare success. By the way, I did change some capacitors out. My capacitor bag is getting pretty full, and my replacement capacitor bag is getting kind of small. So I'm sure Bert will be proud of me changing all these caps. Maybe he'll give me a nickel a piece for these, since they're all good, right? I did find one problem, though, in the kit. This one that's supposed to be 2.2 microfarads, they gave me a 50 volt, as it says on the bag, but really that should be a 160 volt, or at least that's what they put in the radio. Now, maybe 50 volts is absolutely fine, but I would think that would have to be a 250 volt, replacement to be something that you'd expect in a replacement kit. So something's wrong there, or I'm not understanding something. Looks like the AM mod is working on that switch.